Hello everyone, welcome to my channel. So this is the part 4 of the chapter heat. Today we shall study convection and radiation. So let's start. Convection. The transfer of heat due to movement of molecules of the medium is called convection. So here the heat is being transferred by the movement of the molecules of the medium. In case of conduction, in the previous part we have seen that suppose in case of the copper rod, what was happening? The copper rod was getting heated up by the Bunsen burner flame, but there was no movement of the particles. That means the heat was flowing through the entire copper rod, but the copper particles of the copper rod were not moving. But in this case we will see that the movement of the particles is being seen. So let's see. When liquids and gases are heated, heat is carried from one part to another by the actual movement of the hot particles. This movement of particles due to the temperature difference between different parts of the same substance is due to convection. Only liquids and gases transfer heat by convection. Now what does this mean? That heat is carried from one part to another by actual movement of hot particles. This movement of particles is due to the temperature difference between different parts of same substance. Let's take the practical example. A bowl of water. I am heating this bowl of water by any heat supply. Suppose in Bunsen burner we are heating this beaker or a bowl of water. What will happen? We will see gradually the water will start boiling. Now what happens? We are providing heat at the bottom. We are not providing heat from all the sides, right? So as we are providing heat from the bottom, so the water that is present at the very bottom of the beaker or bowl, they will get heated up. But the upper part of the water will be little bit cold in compared to the lower part. Now what happens? This hot water or the hot water particles due to excess heat will try to release this heat. What they will do? That molecules of water will come upwards. Okay, that molecules or that particles of water means that water will completely come up. It is not like that the water molecules will release heat one by one like the conduction in case of solids that we have seen. Here the water molecules will get heated up and they will get, here we will see the water molecules will get at the upper surface of the water and the upper surface water will come down. Only liquids and gases transfer heat by convection. Air is not a good conductor of heat. Being a gas, it can flow and spread fast and also transfer heat by convection. So the air, as we know that air is a bad conductor of heat. That's why we wear woolen cloths that trap the air, which is bad conductor of heat, and it do not allow our body heat to go into the surroundings. Now solid cannot transfer heat by convection because in solids, the constituent particles cannot leave their position. Like in case of liquids and gas, convection process is possible because the molecules or the particles can move from one place to another and it can transfer heat. But in case of solid, the particles are fixed, like in case of copper rod, particles are fixed at their position. They cannot move from one place to another. That's why only conduction process is possible, not convection process. Now we will go through an activity. Activity 5. To show that liquids transfer heat by convection. Materials required. Round bottom flask. Round bottom flask means the flask will be bottom at it. Flask will be round at its bottom. Cold water, potassium permanganate. Potassium permanganate are violet color crystals that are easily available in the market. Procedure. Gently place a small crystal of potassium permanganate into a round bottom flask containing cold water. Like this. Instead of this potassium permanganate, you can use any other colored dyes. Okay, in any other colored solid colored dyes if you have, you can drop into water, or simply for your experiment you can use ujala also. Heat the water near the crystals carefully with the Bunsen burner flame. Observe the movement of the purple colored solution. So if we have potassium permanganate, then we can drop that potassium permanganate at the bottom of the flask and we can see the observation. Now when we heat at the bottom of this round bottom flask, let's see what happens. Observation: the purple colored solution rises from the place of heating, moves a bit away and then moves down to the bottom of the beaker. Means the purple color, from here we will see that it is gradually moving from this part where the heat is been provided. It is getting the colored water, because definitely we have added the potassium permanganate, it will release violet color. So the water from here we will see it is getting rised up at the upper level. So the purple color solution rises from place of heating, means from here the purple color will rise at the top, move a bit away and then moves down to the bottom of the beaker, means it will rise up, then again we will see it will come back. Conclusion: this experiment shows that in liquids heat is carried from one part to another by actual movement of the hot particles, that is by convection. Means this potassium permanganate crystals will release the color, and that particles or the color when get mixed with water, this when get heated up by the application of this heat, it will go at the top and the top molecule of water will come down. Like this, gradually the mixing of the potassium permanganate color in the entire round bottom flask will occur. So this is the process. In the above activity, water near the bottom of the flask get heated first. Definitely this portion will get heated up first. It rises up. The cooler water from the surrounding moves down, gets heated up and rises up. Means the water near to this, water at the very bottom will get rise up, and the water that is present at the top and the surroundings, which is cool, they will occupy the down position. This process continues until the entire water attains a uniform temperature. Means this circulation will occur, or this convection process will occur, that is the hot water from the bottom of the flask will go upward and the cold water from the other places will come at the bottom. And this process will continue till when? Till the temperature of the entire water gets constant, that is uniform. This cyclic movement of water during heating sets the convection current. So this cyclic motion is called as convection current. Air near the source of heat gets warm and rises up. This leaves a gap which is filled by colder air from the surrounding. The convection current thus start in air, resulting into heating of air. Though air is bad conductor of heat, but when heat is applied to air, what happens? They actually start the process of convection, or here also the convection current occurs. The air, the heat source which we are giving, or when we are heating air for a particular place, what will happen? The heat will get transferred from one place to another by the air, by the movement, that is by convection. So air near the source get warm and they get rise up. So when we are heating air, suppose in a room, what will happen? The air which is near to the floor or the bottom, they will start getting heated up and they will rise up. Okay, they will get rised up, and the air that is present at the top will come down. So a convection process will occur and the entire heat will be flowing from one place to another by the process of convection by air. Now, some application of convection currents are described below. Ventilation in rooms. As I was discussing that if we are heating or we are burning something inside a room, suppose in a closed room, what will happen? The air that will get heated up at the air that is present at the bottom of the floor, they will get heated up and they will get rise up, and the air that is present near to the roof, what will happen? They will come down at the bottom or the floor, and this will lead to the convection current. So ventilation in rooms, warm air being lighter rises up and leaves the room through the ventilators provided near the ceiling. That's why ventilators in rooms are very important, because during summer when the room gets heated up, the air that is present near to the floor, they will get heated up and they will rise up. So if the room is closed, definitely the air at the top of the top of the room or near to the roof, they will come down. So cyclic process will occur, okay, and the heat will eventually get distributed. So to avoid this, so that we can release the heat from the room, we use ventilators. As you can see, warm air is getting out. So when the room is getting heated up, the warm air, due to the property of flowing property or the fluidity property of air, it will rise up and it will get out from the ventilators. To make up this, fresh air from outside enters the room through the doors and windows. The convection current so set in air helps in keeping the air in the room fresh. So that's why it is called that to open all the doors and windows, so that fresh air can come in, and the room when get heated up, the hot air can go out from the ventilators, and the fresh air, as you can see, can come from the windows and the doors. Land breeze and sea breeze. This is a very common phenomenon of convection. Land breeze and sea breeze are actually convection currents. During the day, the land warms up more quickly than sea. The air over the land becomes hotter and rises upward. To take its place, the cooler air from the sea moves downward the land. As you can see by the picture, see, this is the sun basically. So during the daytime, what happens? The land get heated up in compared to the water. Okay, the land get heated up more in compared to the sea. So what happens? Definitely the air near the land will get rise up. This is quite obvious. The hotter air from the land will get rised up due to the convection process. Now what will happen? Cold air which is above the sea will occupy this place. So definitely a convection current is occurring. This is called as sea breeze. See, this convection current from the sea to the land is called sea breeze. Means the air which is getting heated up above the land will get rise up and go to the sea, and the cool air from the sea will come here. So like this, a convection current will occur. Now exactly opposite occurs during night. After sunset, land loses heat faster than the sea water. So this is a phenomena which we can see, that the land getting heated up very faster. Now it will release also the heat very faster. Means sea water will get heated up at a slower rate, and it will, when it gets heated up, it will release the heat also at a lower rate in compared to the land. Means when land get heated up, means land gets heated up very faster. Similarly, it will lose the heat also very faster. But in case of sea water, what will happen? The heating process will be also slow, and the release of that heat will be also slow. So after sunset, land loses heat faster than sea water. As a result, the air over the sea is warmer at night. The air over the sea being warmer rises up and take its place. Cooler air from the land start moving towards the sea. So exactly the opposite process occur. What happens during night? After the entire day, what happens? The sea is heated up. Okay. Why? Because slow heating process, and it also releases the heat very slowly. But land, in case of land, when the day is over and during night, we all know that the temperature is quite low in compared to day because sun is not present. So the land will be cooler in compared to sea. So the hot air from the sea will move to the land area, and the cooler air from the land will occupy this space. So here also convection current occurs. The convection current from the land to sea is called land breeze. So this is the sea breeze and land breeze. Sea breeze means the cool air from the sea will go to the land during day, and land breeze means from the land the cool air will go to the sea during night. Now radiation. We feel warm when we sit in the sun, in front of fire, or in front of electric heater. As you can see, this is a fireplace. The heat is been conveyed from this place to here. Is the process convection? Yes, that is also possible. Convection, because the air near this flame getting heated up, and the hot air also can convey. Okay. Conduction, no. Conduction is not possible, because if we directly put our hand into that fire, our hand will get burned. So yes, convection is one of the process, but air is a poor conductor of heat. So how we get the warmth from the flame or the fire as soon as we sit beside the fire? Because for the air to get heated up, it will take time, because air is a poor conductor of heat. So how instantly we are getting the warmth from the heat? This is due to the process called radiation. How does heat travel from sun, from the fire, and from electric heater to us? There is no direct contact between us and source of heat. That is conduction process is not possible. The air between us and the source of heat is bad conductor of heat. That's why convection process is also not that much feasible. Therefore, heat transfer cannot be due to conduction. It cannot be by convection process, because hot air rises up and not towards us. Very true, because hot air. Okay, now suppose the air gets heated up. Okay, but still it will not come to us, because as soon as the air gets heated up, it will rise up. In fact, heat from any distant source reaches us by another mode called radiation. So direct transfer of heat from hot body to cold body, having no contact between them and without the help of any medium, radiation occurs. Why any medium? Okay. So as you can see here, what is the medium between this fire and this girl? That is air. Radiation can also occur when there is no medium. That means in vacuum. That is where there is no air also. In the space or in the vacuum, also radiation process can occur. The sun transfer heat by radiation. All hot objects, whether solid, liquid or gases, transfer heat by radiation. Radiation needs no medium. Transfer of heat by radiation can occur even in vacuum, as I said. Now, reflection and absorption of radiation. When radiation falls on a body, a part of it is absorbed by the body and a part is reflected. Means, suppose this is a surface. So what happens when heat comes to this surface? Some of the heat is being absorbed by this body and some are reflected. So when radiation falls on a body, that is heat radiation, precisely here, a part of it is absorbed by the body and a part is reflected. The absorption of radiant heat by a body causes an increase in temperature. Definitely heat is being absorbed here by process of radiation. So definitely temperature will increase. The quantity of heat absorbed by a body depends on its distance from the source of heat. So definitely the quantity of heat absorbed by a body depends on distance. Suppose here is one object, here is one object. Now heat source is here. So this distance is less in compared to this. So the quantity of heat absorbed by this particle or this surface will be higher in compared to this. So this will get heated up. So distance is one of the factor. Black bodies are better heat absorbers than the white bodies. Black bodies are also better heat radiators than white bodies. So if we take a white body and a black body, we will see that this white body will this black body this is B, this is W. So this black body will easily absorb the heat in compared to white. Similarly, this black body will easily release the heat by the process of radiation. Similarly, in case of the land and sea that we have seen in the convection process, land gets heated up easily. Here also the black body will get heated up easily and release also easily. But white will absorb heat at very slow rate, and the release of heat will be also at slow rate. Now we will learn this black body and white body through an activity. Activity 6. To show that the black bodies are better heat absorbers than white bodies. Materials required: 2 identical tin cans, black and white paints, thermometers. So these are 2 identical tin cans. We can see here that this is painted by white and this is by black. Procedure: take 2 identical tin cans. We have taken one with paint, one with white and black. Done. Pour equal volume of water. Suppose in this 100 ml of water, this will also contain 100 ml of water. Means both the container we will take same amount of water. Insert a laboratory thermometer, as we can see here. Place both the cans in the sun for about an hour. Read the temperature of the water. Means we will keep this 2 tin cans under sun for 1 hour. Now let's see the observation. Water in the black can is found to be warmer than in the white can. How we will notice that? By the temperature. We will see the temperature in the black tin can will be higher in compared to the white can. So the conclusion is, this shows that black bodies are better heat absorbers than the white bodies. So this is the conclusion. By this experiment we have come to know that black bodies are better heat absorbers than white bodies. So thank you for watching. I will share the last part very soon.